As we've seen in lab, chemists report their results in different units. We've seen ppm, ppb, mass percent. I'm going to spend a little more time looking at those. So some of the different ways to report concentration we want to know are mass percent, which is, you can also say percent mass, percent weight, weight, percent. And it's given as the mass of the thing you're interested in over the mass of the solution times 100. You can also report volume percentage, right? For liquids dissolved in liquids, that would be the volume of one thing divided by the volume of the solution times 100. You also have mixed percentages, where it's mass, volume percentages. So the mass of the solute in the volume. So it's sometimes reported mass, volume. So if you have the percent and then it's reported volume, volume, or percent mass, mass, or sometimes percent weight, weight, these guys are the same, then weight, volume. And with percentages, you really have to specify what you're talking about. I guess one thing that makes it fairly easy is that 1 milliliter of water at room temperature equals 1 gram water. So that's a pretty easy conversion. And then finally we saw parts per million and parts per billion, right? And what we said was ppm can be given as a milligram per liter. So then a ppb would be microgram per liter. All right, mole fraction we've seen before, Rao's law. So it's the moles of the solute over the total moles in the solution. Molality is a new one. So molality is little m. It's the moles of solute per kilogram of solvent. It's similar to big M molarity, which is moles of solute divided by liters of solution. But it differs in that this liters of solution combines both the solute and the solvent, whereas this guy is only the solvent. So molality and mole fraction is concentration is, what is this? This is a disaster. It is the mass of the solvent, right, in the denominator, right? And this is important because with molarity, where the volume can change, right, as temperature changes, you'll have different effects. Where these guys, mass percent, mole fraction, molality, are independent of temperature, and so they're used for different kinds of calculations. So we'll look at those now. So go to black pen. Thin lines, thin lines. How many grams of HCl are there in 200 grams of a 10% by mass solution? So here's my formula. So mass percent, 10% equals the mass of the component, right? I'm interested in the grams of HCl over the mass of the solution, 200 grams, right? If this wasn't written right here, I would write it down, times 100. Okay, so if I solve, I divide both sides by 100. I get 0.10 equals grams of HCl over 200 grams. So the grams of HCl equals, multiply both sides by 200. I get 20 point, let's call it 20.0 grams of HCl. All right, so that's just using mass percentage. An aqueous glucose solution is 8.1 millimolar. All right, so now we're doing a conversion here. So what's that in grams per liter? So what I do is I write down 8.1 millimolar, which is millimoles per liter, and it just becomes a conversion problem. So I need to go between millimoles and moles. So millimoles, I want to cancel goes on the bottom, moles goes on top. 1 mole equals 1,000 millimoles. So now in moles per liter, and I want to get 2 grams per liter. So I need to take 1 mole of glucose and turn it into grams of glucose. And the molar mass of glucose just happens to be 180.2 grams, right? That's from the periodic table. We added it up. Oops, equals. So if I punch that all in, I get 1.46 grams per liter. But let's just double check I did that right. So millimoles canceled millimoles. Now I'm in moles. Moles canceled moles, and I'm in grams per liter. Check. All right, so 8.1 millimolar solution is 1.46 grams per liter. next. The EPA mandates lead concentration less than 15 parts per billion. If 100 grams of water sample contains 0.0225 mgs of lead to, what is the concentration in ppb? Well, we need to turn that into, oh, weird, yeah, we could use that calculation. Oh, let's do this. So we could turn it into micrograms per liter, or same thing here. So we want to know the ppb. ppb equals the mass of the solute. Oh, that would have to be grams. Okay, so we're going to have to do some conversions anyway. 225 milligrams of Pb2 plus. I want to convert that from milligrams to grams. So 1 gram is 1,000 milligrams equals 0.1231225 grams Pb2 plus. 10 to the negative 5. 1, 2, 3, 4, 5. Yep, okay. So 2.25 times 10 to the negative 5 grams divided by the mass of the solution. Grams is 100 grams times 10 to the 9th equals, and I punch that in, I get 225 ppb. Right, we could also have figured that out as micrograms per liter, right, or micrograms of lead per 1,000 grams. Either way, all right, so just doing calculations with those. All right, here is a fun one, doing a whole bunch of these conversions. So we're going to look for mole fraction, mass percent, molality, and molarity of this ethylene glycol in your radiator. So there's 1.2 kilograms of ethylene glycol added to 4 kilograms of water in the radiator. What are these different things? So let's see. So to calculate molality, I need to know the moles of ethylene glycol divided by the kilograms of water. Oh, I already know kilograms of water. Nice. Mole fraction, I need to know moles ethylene glycol over moles total, so it'll be moles of water plus moles of ethylene glycol. Mass percent, I need grams of ethylene glycol, mass of the solution divided by grams of ethylene glycol plus grams of water. Molarity, I need moles of ethylene glycol divided by the liters of total solution. Just wrote that twice. All right, so it looks like I need the grams of ethylene glycol and the moles of ethylene glycol, and the grams of water and the moles of moles of water. So let's do that. So 1.20 kilograms of ethylene glycol. Let's turn that to grams. Let's see. Kilograms goes on the bottom, grams goes on the top, and there's 1,000 grams in a kilogram. So that will be 1,200 grams ethylene glycol. Do the same with water. H2O. 1,000 grams is 1 kilogram. It's 4,000 grams water. And then we got to turn 1,200 grams of ethylene glycol into moles. The molar mass, nice, is 62.1 grams. Mash that in. We get 1,200 divided by 62.1 is 19.3 moles ethylene glycol. All right, and then 4,000 grams water. 1 mole of water equals 18.02 grams of water equals 4,000 divided by 18.02. 221. I'm going to go to 2. It's 221.97, so 3 sig figs. We should go to... Oh, it was 4,000. That should be 3 sig figs. Okay, we'll go to 222 moles of water. All right, I think we have all the parts. So let's do mole fraction first. So X of ethylene glycol, or Chi, right? Mole fraction of ethylene glycol is going to be moles of ethylene glycol, right? It's all up here. Moles of ethylene glycol is 19.3 moles of ethylene glycol over moles total. So it'll be 19.3 moles plus 222 moles, and that equals 19.3 divided by 19.3 plus 222 in parentheses gives me 0.0, whoa, let me write this down, 0.07998. So we better, what are we going to, we got to go to the 3 sig fig, so 0.0800. All right, so that's the mole fraction of ethylene glycol. Nice. Next, one down. How about molality? Little m is moles of ethylene glycol. Right, reading from here. Ethylene glycol we have is 19.3 moles ethylene glycol divided by kilograms of water. Here we go. 4.00 kilograms of the solvent, which is water. And the molality then is 19.3 divided by 4 is 4.83 molal ethylene glycol. There we go. Mass percent is the grams of ethylene glycol, 1,200 grams of ethylene glycol over the sum of the 2 grams, everything in the solution. Grams, nice. Mash that in. Oh, times 100 equals 1,200 divided by 1,200. Oh, I could have added that. Oh no. 100 divided by 5,200 equals 23.07, so 23.1% ethylene glycol, right? Mass. What do we got left? Molarity. All right, let's take a look. So big M molarity is moles of ethylene glycol. We've got that. It's 19.3 moles of ethylene glycol. Okay, and we have to divide by the volume of the solution. What? We actually need the density here, but let's see. So do we know the volume? No. We know the total mass of the solution. What's the total mass of the solution? We already used it here, didn't we? That's the total mass. So if I took the mass, right, let's see, density equals mass over volume. So then volume equals mass over density. So let's assume that the density of water is 1 gram per mil, even though this isn't, bad work by me. This isn't a pure solution of water anymore. Really, it's a solution of ethylene glycol and water. So this density is probably not exactly 1, but we'll use 1 here for ease. But you could use the real density. So let's see, let's solve for that then. So we said the volume will be the mass, 5,200 grams, right, times the density, divided by the density, which is 1 gram per milliliter. So we get 5,200 milliliters, and bad planning, 5,200 milliliters times 1,000 milliliters, or divided by 1,000 milliliters, that, so 5.2 liters. Yep, well, so based on using this density, which is probably not true here, right, we do need the density to get here, but we'll get this, it'd be 5.2 liters, and if I solve that, I get 3.71 molar. All right, so that's the only tricky one, right? And what we're doing is we're going from the total mass of the solution using the density, right, to get the volume of the solution. And how I get the total mass of the solution? I added up the masses of the components. All right, so that is fun with molality, mole fraction, mass percent, and molarity. And we're going to go ahead and use molarity later on. No, sorry, molality later on. And just as a quick review of, the way analytical chemists get these concentrations, right, by gravimetric analysis, combustion analysis, and titration reactions. Remember what these are. So combustion analysis, remember, this is when you burn something in oxygen to get CO2 and water, right? A combustion reaction is reaction with oxygen making CO2 and water. If you're able to collect the CO2 and collect the water, you can use the mass percent to solve for the amount of H, the amount of C, right? If you know the original sample of the mass, then you now know how much H in there, how much C, how much O, if there is anything. So we can figure out the percentages there. Precipitation reactions, right, is what we use to do gravimetric analysis. So if you get the mass of the precipitate, right, mass percent, you can figure out how much of your analyte is in there and go back and figure out the concentration in the original in ppm, ppb, mass percent. And then titration. Remember, at the equivalence point, the moles of the one thing equals the moles of the other. These are different ways to figure out these concentrations we just talked about. Colligative